Astronomers have made a groundbreaking discovery about the interior structure and evolution of stars. Thanks to the Atacama Large Millimeter Array radio telescope network in Chile, operated by the European Southern Observatory, they have been able to observe in detail for the first time the giant bubbles on the surface of a star other than the Sun. This star, called R Doradus, is a red giant located about 180 light-years from our solar system. The production of energy in stars and the mechanisms by which this energy is transported to the surface have long been among the most curious questions for astronomers. The enormous energy produced by nuclear fusion reactions in the cores of stars is transported from the inner layers to the outer layers through two main mechanisms, radiation and convection. In low-mass stars, energy is transported by radiation in the inner layers and by convection in the outer layers, while in high-mass stars, the opposite is true. The granules observed on the Sun's surface are the most obvious examples of convection. These granules are cells formed by the rise of hot plasma to the surface, cooling, and then sinking back to the center. Thanks to being the closest star to us, we have the opportunity to examine the Sun's surface in great detail. However, other stars, due to their distance from Earth, generally appear only as points. Therefore, it is quite difficult to obtain information about the structures on the surfaces of other stars. Red giant stars like R Doradus are massive stars, hundreds of times the size of the Sun, that are in the final stages of their evolution. The giant bubbles observed on the surfaces of these stars are a larger-scale example of a similar physical process to the granules on the Sun. These bubbles form as hot gas from the interior of the star rises to the surface and cools, then sinks back inward. During this process, heavy elements from the star's inner layers are also carried to the surface, enriching the star's atmosphere. The giant bubbles observed in R Doradus provide important information not only about the structure of the star but also about the evolution of stars. Stars like the Sun will also become red giants in the advanced stages of their evolution. Therefore, studying R Doradus will help us understand the future state of the Sun. This discovery will enable astronomers to better understand the interior structure and evolution of stars and provide more information about the formation, life, and death of stars. In addition, such observations can play an important role in our search for life in the universe. Because such activities on the surfaces of stars can have significant effects on the formation and evolution of planetary atmospheres. In conclusion, the giant bubbles observed on the star R Doradus are an important discovery that provides a deeper understanding of the physical processes of stars. This discovery has opened up new horizons in both fundamental scientific research and space science. The giant bubbles observed in R Doradus provide important information not only about the structure of the star, but also about the evolution of stars. Stars like the Sun will also become red giants in the later stages of their evolution. Therefore, studying R Doradus will help us understand the future state of the Sun. In addition, such observations can play an important role in our search for life in the universe. Because such activities on the surface of stars can have significant effects on the formation and evolution of the atmospheres of planets. This discovery will allow astronomers to gain a deeper understanding of the internal structure and evolution of stars, and will allow us to learn more about the formation, life and death of stars. In addition, such observations will allow the development of new theories in astrophysics and the testing of existing theories. In conclusion, the giant bubbles observed in R Doradus are an important finding that fundamentally changes what we know about stars, one of the most fundamental building blocks of the universe.